Okay, hi everyone, I'm Kai from the flight simulation team. Today's presentation will cover my progress from last week and this week and the outlook for the subsequent weeks. So last week, Mark and I, we mainly focused on literature review. So we looked at the US Naval flight test manuals, from which we extracted the flight test procedures for a majority of the maneuvers that we want to conduct. And yeah, we read up on X-Plane, Planemaker and the Airfoil Maker manuals. Yeah. And Mark and I came up with a list of flight test procedures shown here. So this is just a sample of our flight test procedure for takeoff. And we have only completed for the airborne phase because the maneuvers for the other phases are going to be similar. Yeah, so this is just a sample. And for this week, we started modeling the aircraft with the CPIC given to us by the coordinators. We started to model the CPIC in X-Plane using Planemaker. And the table shows the breakdown of the allocation of the task between Mark and I. So I'm going to talk about my aspect of the modeling, which is aerofoil. So I modeled NACA 1410 in Airfoil Maker. I had to model it from scratch because the database did not contain this airfoil. So basically what I did was I used airfoil tools to generate the geometry of the airfoil, which I then imported into JavaFoil. And using JavaFoil, using JavaFoil, I generated the characteristics of the airfoil at two Reynolds number. A low Reynolds number of 500,000 and a high one of 50 million. The reason for this will be explained later. Yep, so this is the interface of Airfoil Maker. As I said previously, with the characteristics generated from JavaFoil, I basically have to duplicate that characteristics in Airfoil Maker. So I have to key in values such as the zero intercept, the slopes and stuff to get the curves to look exactly like what came out in JavaFoil for the two different Reynolds number. And it's quite a crude method because I'm supposed to tweak with these values until I get the right curves that I'm satisfied with. And once I'm satisfied, I'll save the curves under the name of the aerofoil and the Reynolds number that it was generated in JavaFoil. Then after I'm done with the aerofoil, I moved on to model the aircraft, specifically the lifting surface and the control surfaces. So yeah, the next slide will show you the interface of Planemaker. So this is how to create a wing in Planemaker. You come to this tab, and in Planemaker you can separate the wings into up to 4 sections. But as for the CPIC, the wing was relatively simple, so I used only one wing section to create it. So in the left-hand upper box here, you can specify the specifications of the wing. So like span, chord, sweep, and dihedral. For that box over there, you can define the texture and the appearance of the wing, but I'll leave that out for now. And then, yeah, as I said, you can split the wing into 4 sections, but then the different tabs will allow you to model each section separately. But within each section, you can further split the wing into up to 6 panels, and this is where X-Plane will carry out the aerodynamic calculations during flight. And coincidentally, after you split them into panels, you can specify what control surfaces you want at each panel. Yeah, and also you can specify the incidence at each panel, so we can model the wing twist. Yep. So as for the fuselage and the undercarriage, was modeled by Mark. And after we have completed everything, we flew the CPIC in X-Plane 7.63. Our joystick lacked yaw control, so it was rather difficult to control the plane. Yeah. And we have some videos of our flight. So, video 1 shows the first flight of the CPIC.
With totally random numbers, I expect, right?
because the Pro E model didn't specify the control surfaces, so I randomly assigned control surfaces, and the engine wasn't specified, so we fitted it with a rocket engine. So this is the first flight of the CP. Yeah, as you can see, we kind of screwed up the location of the CD, so we went into the counting mode. Yeah, and video 2. Video 2 is after we rectified the CG, so it could take off properly.
Afterburners.
There's an inherent yaw to the left because of the lack of yaw control in our joystick. Yeah, so this is how the CPIC looks like.
So we're done. The CPIC can fly.
Yeah.
Okay. That's it.
You see our constraint diagram only do 30 degrees roll. I think it's more than 90 degrees.
Your constraint diagram also does not assume afterburning engines.
Yeah,
So
okay, so at the last slide of my presentation, I'll recap our project timeline, so I'll outlook for the following weeks. So Mark and I hope that we will be able to obtain preliminary CAD design of the actual plane, so that we can begin modeling it in Playmaker. Yeah, and we will continue to get to grips with flying in X-Plane. Yeah, that's about it. Yeah.
I only have one comment, really. Airfoil data. You have to wait for aerodynamics to obviously give you proper data. Be weary of the CO max values that you get from shallow foil, undoubtedly. The only other thing that I'd like to remind you of is that we also have a waterborne takeoff and landing to do here.
Yeah.
It would be nice to see it explained capable of actually modeling the water properly, and
we tried flying the seaplane that came with X-Plane. 415. I can't remember what's it. Canada Air?
the big yellow one.
Yeah, the big yellow one. So we tried to take it off from water. And, the X-Plane generated waves and stuff. We can change the sea state to like 300 feet waves and stuff.
Okay, forgetting about sea states, one thing that you might want to see is if with this model, which is actually quite good, it comes with X-Plane because it's typically validated, whether you can achieve the takeoff distances at different loads that are actually advertised for the particular aircraft.
Okay.
Yeah, and try and hone your technique.
You know, for the airfoil data, could we actually co-join and give the data to them and hold in the share? If when they do the airfoil maker, they purely rely on Java foil, and we know it's not.
No, they rely on your data, on
just
your
gonna match
information.
it. So you're just gonna match it. Okay.
He's going to tell me what aerofoils they used, and I'm going to get the geometry from
The geometry doesn't matter in this.
Yeah,
everything's
if
a
you
double
can
O
specify,
12.
you can give me the curves, then I'll just match according to its curves in Airfoil Maker.
For the CL performance.
CL, CD, and CM. I just need to match these three curves in Airfoil.
How do we calculate CM? Because when we do pedal code, they'll say, oh, like soil again.
X4 has CM and
No, but it's at the end of the day, it's X4 again.
Well, things like CL Max, you may want to look at empirical methods or semi-empirical methods. ESDU, the ones in .com, they're all quite good.
X4 will give you CP plus, so you can get CM from there if you need to. It doesn't give you integrate. Sure, it should give you.
X4 gives CM.
Sure, it gives CM.
There's one more thing. I think just now I mentioned that I created two plots for 50 million Reynolds number and 500,000 Reynolds number. The reason why this is because X-Plane Playmaker allows you to assign two airfoils to each wing section, at the root and at the tip. So at the root I can assign two aerofoils, and at the tip I can assign two aerofoils. And for example, at the root I'm going to assign the NACA 1410 airfoil at 50 million Reynolds number, and I'm going to assign the one at 500,000 Reynolds number. With these two aerofoils, X-Plane will interpolate between these two plots to make in-flight calculations for the lift, drag, and moments. Yeah, it's just one thing I forgot to mention.
It interpolates between two different rows.
I'm just wondering, the accuracy we can get from XY, we know that it's not. It could be wrong sometimes.
If there are regions of your curves that are where potential flow with small corrections is valid, then you're fine. But if you're no longer within the small corrections regime, then you need to find other methods of doing it.
X4 is very good until you get separation. I wouldn't have any problem under 10, 12 degrees. It's pretty accurate.
But can we actually control the flying angle and stuff to be not too severe?
Well,
Within the utility category.
Sorry?
Do you know, like the flying rolling angle,
Yeah.
yaw, etc.
Can we control?
As if not exceeding what we designed it for, if you know what.
Like,
So we follow the that standard or whatever standard, and we suddenly fly the simulator in a turn like this. Seems like it's not matching up.
There's a warning.
yeah, there are
Well,
warnings.
what you saw from your constraint diagrams is that the 30-degree turn was not actually your constraint, so you definitely have thrust to do more than the 30-degree
So
turn.
turning is just one of them. I'm just saying, like severe, we want to.
No, it's not a fighter. You don't need a crazy constraint for that, I would say.
Have you tried having a ground effect flight yet?
No, we have not tried anything. We mainly be focused on the airborne phase.
Yeah, I'm not sure to what extent ground effect is counted. There's no.
Ground effect can be modeled in XFL.
Huh?
In XFL.
And we're talking about. They're definitely not core time.
Don't worry about Gordon.
Are there any more questions?
Thank you for your time.